Go.
All right. So today I'm going to talk to you about our experiences building a software as a service using CoreOS and etcd. You're going to hear a number of terms and phrases that you've already heard today, so things like microservices and things like service discovery. But first, a little bit about me. So I'm the founder and CEO of a company called Yodeler. As I also help run Baynode, which is a Bay Area Node.js meetup. So if you like Node, I'd love to talk to you. I'm also involved with IOJS as evangelist. I love soccer, and you can find me on Twitter at Kukulinski or via email as well. So I want to first talk about what Yodeler is and why we built it. So Yodeler is a browser-based communication platform. It's kind of like Google Hangouts or Skype. It runs in your browser, no plugins, no downloads, no user accounts. The whole reason we built this is because we were fed up with all the other communication platforms, and we built it originally as an internal tool. My team here that's based in California is working, we're the future tech group for a company in DC, and the parent company builds communication systems for flight simulators and military training. They've been doing that for 25 years. And so we're communication people, we're audio people, and we got frustrated with all the other tools, and we said, let's just build our own little tool, little web app that allows us to communicate and effectively work with the rest of our teams. So that's what we did. And then it became no longer an internal tool. We started using it for some of the open source work we were doing it. Some of our sales and marketing teams started using Yodeler as a communication platform to do selling to customers. But we had some customers that were more excited about Yodeler than they were about the flight simulation products that we were trying to sell them. So that's when we realized that we had a product that we wanted to try to commercialize. The problem was my team had built Yodeler in a 3-week sprint. And it was this one giant monolithic hacked-together thing. And it was great for what it did, but in terms of scalability, in terms of maintenance, in terms of trying to build a business around that, we needed to completely reimagine and re-engineer the product. So as strong supporters of the Unix philosophy, we really, really love and appreciate this idea of building applications that do one thing, and they do one thing well. We also love to do A/B testing. So we wanted to be able to deploy multiple versions of the same application side by side and do, whether it's performance capabilities or being able to do rolling deploys of new features. We also wanted to try to eliminate this idea or this problem that we'd encountered of, it works on my machine, so it's not my fault that it doesn't work in production. Of course, Yodeler is going to be amazingly, everyone's going to want this, so we need to be scalable, we need to be fault tolerant. And then because we're a small team, we're application people, we're audio people, we don't really want to spend a whole lot of time doing DevOps. I am the DevOps for the team, so I would like to do as little of that as possible. So we sat down, we started drawing out and started experimenting, and this is what we've built. So first of all, Docker. We've heard Docker over and over again. I'm going to use Docker here because instead of the general containerize or containers, because we are actually using Docker in our infrastructure. We don't have to be using Docker, but I like a lot of the infrastructure that already is part of Docker. So by using Docker, we're able to reduce our application complexity by taking this one monolithic app, and we broke it up into a bunch of smaller microservices. Some of them are REST APIs, some of our streaming audio processing, some of them are doing the audio mixing. And by having these containerized applications, we can now run multiple versions of the same app on the same host or on different hosts, and they don't conflict with each other without having to write very complex tooling for our packaging. We didn't want to create our own packaging infrastructure. And because Docker containers are self-contained, the container that I build on my desktop or my Mac is going to be the same thing that's going to be we're going to run tests against. It's the same container that we run in staging, and it's the same container that's in production. So if we're able to, if we see a problem in production, I can go download and grab that exact version that's running to my laptop and start running against that. Then the question came up, how do you ship Docker containers? And that's where we came across CoreOS. We're working very closely with Rackspace, and Rackspace had initially shipped a platform called OnMetal, which is basically you use cloud APIs, you're able to provision a physical hardware machine in their infrastructure. So you get bare metal capability, but you can use cloud-based sort of REST APIs or clients to do that. And as we were sort of experimenting and talking with them, they said, hey, you got to go check out this CoreOS thing. So what is CoreOS? So CoreOS is a very minimal operating system. It's built pretty much to run Docker containers. or containers. In terms of the DevOps world, some of the things that I was particularly excited about, CoreOS by default has this idea of automated software deploys. So they use the Omaha protocol, which is part of what your Google Chrome browser uses to run auto updates. It's the same principle, but you apply it to the hosts in your data center. So I really no longer need to worry about, oh, there's a new vulnerability out. Well, I check the maintenance list for CoreOS. They're usually really quick about turning those releases. I can see the deploy happen across our infrastructure. Done. I don't have to worry about it. CoreOS runs in all the major cloud providers. And again, for us, because we're doing real-time audio, we need very high-performance back-end systems. So CoreOS is ideal to run on bare metal, which means that our Docker containers are effectively running on the bare metal machine, which means that we get great performance. CoreOS is also fault-tolerant and scalable out of the box. So it's clustered by default using etcd. We've heard that a couple of times today. It has support. etcd can be clustered across high availability zones. So you can handle downtime in one data center, and your overall infrastructure is not impacted, at least hopefully not too badly. etcd is a key value store, so it is a database. And as a database, it's going to enable you to build things like service discovery and using Fleet, which runs on top of etcd, things like basic application scheduling. So with those, with CoreOS and Docker, we've checked everything off of our requirements list. Yes! But there definitely, as we were building this platform, there was definitely some things that were missing from the infrastructure. We first started building this in about July of last year. And it went into production in November, and we've been running production since then. And so, as with all new systems, new infrastructures, there comes a time where you just want to throw your computer out the window, just march away, have a cup of coffee. Then you've got an idea, and you come back and you test it, and maybe it works, and then you come across another thing. So I want to share a couple of the aha moments that we had while we were building the Yodeler platform. So number one, etcd is a database, and you should treat it like one. So you need to give etcd its space. So if you've got a MongoDB or a Redis or a Postgres database, you wouldn't run hundreds of your application programs on the same physical host machine as your database. You just wouldn't do that. But if you read some of the etcd and CoreOS like getting started guides, like the first CoreOS cluster you're going to bring up, it's going to look like just the thing on the left, where you've got 4 or 5 hosts that are running etcd, and your applications are running on that. And that's great for prototyping. It's great for dev. Do not ever do that in production. And the reason is you want etcd to have the full capability of the platform that it's on, so it's not getting affected by the rest of your scheduling. And etcd, especially in etcd 2.0, which is just now rolling out into the alpha channel of CoreOS, is this idea of etcd workers or proxies. So you can have a whole cluster of machines on the right that are part of your Amazon auto-scaling group or whatever that come and go based on your demand on your services. They simply make requests to your core etcd database on the left. Number two, etcd is a database. And it's not just a database that the CoreOS system and Fleet are used. It's a database that you can put information about your infrastructure into. And Luke talked about this earlier, about this idea of doing service availability and the sidekick or ambassador pattern. The basic idea here is we've got a REST API. So it's running in a Docker container. We use Node a lot, so all of our REST APIs are Docker. This Docker container needs to advertise its existence to the rest of the infrastructure. And that's where we have this idea of a sidekick. And so what the sidekick is able to do is by using Docker inspect, it can find out what are the IP address and port that this container is listening on, that it's accepting requests on. Second piece, do some health checks. Yes, this container is running, but is the application that's in the container, is it running properly? Is it reporting a successful health check? And finally, number 3, publish that information and any other sort of additional metadata about that instance to etcd. And the sidekick and the REST API, they're fundamentally tied together. This sidekick speaks the language of this REST API. And that way we can build special health checks that actually can verify that the service is running and is operating correctly. And once you've got this information in etcd, now you can do stuff with it. So for incoming requests, you want to be able to proxy requests to one or more of those microservices running. And we're using something called conf-d, just built by Kelsey Hightower. He's on the CoreOS team. And Luke is also using this in PaaS, and it's a pretty common platform. And what conf-d does is it periodically queries etcd for information about upstream services. And then it updates the configuration file for Hotproxy or Nginx, and you can use it for anything. So if you want to use it with RabbitMQ or some other sort of style system, you can dynamically re-update your configuration file for that program, and then conf-d will reload or restart that process anytime there's a change. So that means that for me as a developer, I can define a whole pool of resources of REST API services, and I can have one or more of these HA proxies that can do all the proxying, and it's all dynamic, and it all happens behind the scenes. I do want to give a quick shout out to, there's a program called Vulkan Proxy. It is built by the Mailgun folks. They claim that it's still not production ready, and I believe them. But it's really cool, and I think it's the right direction. And Vulkan basically eliminates this need for the HA proxy config piece. You don't have to build the special container. And instead, they've done a lot more complex things with being able to do versioning of your services in etcd. You could, in theory, build that in with this conf-d thing, but I'd much rather use somebody else's code that they've built and tested and then help them build and test it more. So we're keeping a close eye on Vulkan Proxy. Now, another big problem that we ran into is we've got this CoreOS cluster. We've got our internal HA proxy load balancers that are relaying traffic. But how does an end cell phone or an end mobile device or computer, how do they actually get to this wonderfully load balanced system? Well, so we took advantage of external load balancers. So whether you're using, if you've got Amazon's ELB stack, or in our case, we're using Rackspace's cloud load balancers, we have our DNS entries point to those external load balancers. But what's cool is the configuration of those load balancers is all dynamically driven by data that's inside of our etcd. So our top-level HA proxy load balancers, they themselves also have sidekicks that report their state and what service they're providing to etcd. So that our LB config system here can dynamically reconfigure our Rackspace. So that way, as our CoreOS cluster comes up and down, it's got auto-scaling, we don't have to worry about the external requests coming in. They're all going to be handled and dynamically updated based on etcd. So number 3, what do we think number 3 is? It's a database. And you care about what's in your database. We're talking about very, very important private information you're going to be storing in this database. And so you need to protect your database. So I've got 2 sort of public security announcements. Number 1, if you're following the CoreOS documentation, if you're deploying on Rackspace or Amazon, whatever, they use this special magic thing, private IPv4. You should think very carefully about what that private IPv4 is. Oftentimes on DigitalOcean or Rackspace, and I'm not 100% sure on Amazon, that private IPv4 is considered the service net. It's a shared network with other customers of that cloud provider. It's not necessarily a private IP address to you, it's private not to the public, which means that other people in the cloud that are running next to you could read all of your database information, dynamically reconfigure your external load balancers. So be very careful with that. The way that we've solved that is when we bring up our CoreOS clusters, we have a separate private network in Rackspace, and you can do this with Amazon. And we have a service that runs on boot that dynamically updates these private IPv4 information to actually use our private network. So we have etcd that runs on that private network. You can also, if you need to run etcd over a public network, if you're doing across data centers and you don't have a private VPN link, then you can use, you can encrypt the connections between etcd. We went through that as an experiment, and it was a bit of a nightmare. I think they're working on that, trying to make it better. I think the etcd 2.0 should help with that. But when we first set this up, it was not worth the effort for us. We just ran private network. Number 4, Sometimes you just need a GUI. I love command line tools, and Docker and CoreOS both have great command line tools. But if you are monitoring and managing 50, 100, or 200 services that might be running on your cluster, it very quickly gets cluttered. So something that my team built is something called corgi. Corgi is basically a simple listing of all of the information that fleet control and etcd, which basically track the information of what's running in your cluster and what data is in etcd. It's basically a simple Node.js Angular app to monitor all of that. And then some folks, we set off and built this ourselves, and then later on we found the people creating Fleet UI were working in parallel on the same problem. So I think some of their feature sets are more advanced in terms of like tailing logs and other things, but find the tool that works for you. So one of the things with CoreOS is they have this idea of a unit file. And unit file describes the Docker container or the workload that's going to run. It's effectively a systemd unit, and they've got some additional metadata, so things like being able to additional scheduling information of where to put containers. And one of the nice things that we do like about Fleet is it allows us to define a template service. So like if we've defined this REST API service, the little @ symbol means that it's a template. And so we can bash expand, like if I'm doing a fleet control start REST API @ brackets 1.3, that will expand out and start 3 instances of that service and spread them out across the cluster. That's awesome. It's really, really convenient. However, getting back to the fact that we want to run multiple versions of the same application, or if we're doing rolling deploys and we've got lots of versions out there, we needed a way like one step further beyond this. So specifically, we wanted to define our service files in terms of not only the service name, but also the environment. Are they production? Are they staging? Are they a test piece that we're sort of experimenting with service? And then tag here for us is actually the git SHA of the commit of the software that was triggered that build. So that means when we're looking at the listing of all of the containers, all the services that are running our infrastructure, we can see a given git SHA tag, or sometimes we also were experimenting with showing like the Jenkins build number that was associated with that. We can see exactly which versions of which applications are running in our infrastructure. And so we've built a little templating engine that basically takes a file like this, including the file name, and then spits out a nice templated service file. So the last piece here is containerizing your tooling and builds. And the inspiration for me, I first met Jessie at a little one-off meetup kind of event. And she it was like the first version of the talk she's going to do later today. Do not miss it. You have to stay and see what she's going to talk about and demo with Docker. Super awesome. And I'm not going to steal it from her. But it gave me the inspiration to say, hey, why are all of our tooling, all of our scripts, all of our build services, why are they not in containers? We can put everything in a container. I can bring up our entire Jenkins build suite as its own infrastructure, and I can run it on my laptop. So if I'm testing that piece of the infrastructure, or if I want to test the templating engine, this thing that runs this, it's a Docker container. I can run it locally, or we can run it in our infrastructure. So I think that's something that probably was the most recent aha moment, and we're still building out tools and doing things like running Jenkins slave in a container, building and testing our applications in a container. So containers are awesome. We love CoreOS, we love Docker, and you can get really far with Fleet and etcd, the tools that come directly with CoreOS. However, if you're building more complex systems, or if you have really massive workloads that need particular scheduling systems, I think that the Fleet and etcd are going to fall short unless you write lots of extra additional software on top of that. So I think in that case, you may want to look at some of the things you can put on top of Fleet and etcd, so things like Mesos. I'm very excited about Kubernetes. I think this summer, as it's getting closer to 1.0, we will probably start evaluating all of our services and trying to put them into Kubernetes pods and start testing that in parallel with the rest of our infrastructure. And then finally, remember, etcd is a database. Treat it like one. Thank you.